This is our third video in the series looking at R programming. We're still going through just the basics at the moment. R is a free statistical programming tool that is linked below in the description, and we'll get right in to some more dealing with vectors. Right, we're going to be very creative and call our first vector vector1, defining it in one of the ways we introduced in last video. So if you haven't seen that, then be sure to go check that out. So our first vector is 3, 6, 1. Vector 2 is going to be defined as, what should we go for? 9 and 1, 4. Okay. Now when we do vector 1 and we add it to vector 2, that's not a 2, right. What are we expecting to happen? Well, each vector has 3 elements, and so we should get each corresponding element added to each other like you would get in basic vector addition anyway when you're doing it by hand. Alright, so we get 3 plus 9 gives 12, 6 plus 1 gives 7, 1 plus 4 gives 5. Okay, brilliant. So that's what we were expecting. But now if we define vector 3 and we give it, say, instead of 3 elements we give it 6, okay? And I've typed in vector 2, brilliant. Vector 3, sorry. Right, and we give it 6 elements. Perfect. Now we want to do vector 1 plus vector 3. And if we were doing this by hand, we'd say this is impossible. You cannot add 2 vectors at different sizes together. It doesn't really make sense. But R will do it, and it has a way of interpreting it, and we'll look at it now. My bad, there's a space between vector 1 and 2. Vector 3, there you go. Second time lucky. I don't even know how to use a keyboard, and I'm trying to teach you some stuff. Anyway, right, it does vector 1, so we get 3 plus 3, 6 plus 6, 1 plus 1, as you'd expect. Okay, if the vector cut up here, that'd be fine. But then we get 11, which is 8 plus 3, 8, which is 6 plus 2, and 5, which is 1 plus 4. So what R is doing is, when it gets to the end of vector 1, which is the smaller of the vectors, it's just cycling back through the elements again. Unfortunately here, when you cycle through vector 1 twice, you get 6 elements, so it manages to do 2 full cycles of vector 1. But this isn't always the case. If we define vector 4, no space this time, we do see, although, you know, my terrible mistakes today do highlight the point with computing a lot. You have to be very careful what you type in. You will make some mistakes, so make sure you check every line after you put it in. 2, 5, 1, 7. Okay, so this has 4 elements. And we can check this length as well, just to tie it into some of the previous videos we've done. The length of vector 4 is 4, okay, so we know it's got 4 elements. Now we'll do vector 2 plus vector 4, and you see it comes up with this warning message. Long object is not a multiple of the shorter object length, and that's basically saying that 3 doesn't divide 4, so 3 doesn't go in to 4 in an integer multiple. So, but what it's done is where's our vector 2? It's done 9 plus 2, giving us 11. It's done 1 plus 5, giving us 6. It's done 4 plus 1, giving us 5. And then it's gone back to the start of vector 2, and it's done 9 plus 7, giving us 16. So that was the point I was trying to make. It does cycle back round, even if it can't do full cycles, but as you've seen, I will give you a warning just in case you didn't realise this was real, or you weren't intending to do this, because it is a little bit unusual as a thing to try and do, but we're just trying to demonstrate a point. Just for completion, we can look at vector 1 subtracted by vector 2, just so you can see the same sort of principles work with subtraction. But other than that, that's it for this video. If you did find it helpful, please like and subscribe and share it with any mates that you think might be interested. But yeah, that's it, and I hope to see you in the next one.